and here. This works. I'll also do the thing where I put it on full screen.
I still don't see the stream on YouTube started. Sure, if you started it. Oh yeah, now it's starting. Good.
Yeah, it has like there's like a slight delay to have a buffer and get things go wrong.
Mm-hmm. Good.
I'm going to do the thing I did just the last week. To increase the size. I could do.
I'm gonna restart my own operating system. Wait a second. Yeah.
This one works. Okay. Okay. This works. It's streaming on YouTube. Okay, doesn't matter. So as I was saying, let's look at the lesson post. So this week we picked this lesson post, but it's not as long. We will probably also look at the Scratchpad thinking paper that's looking at similar stuff if we have time. But yeah, let's see it. As always, I'll be looking through the thing myself, but feel free to interrupt at any moment and say anything, and say any comment or question you have, and maybe we can look into it. Yeah.
I wonder which latent reasoning paper it is exactly. I just know most of the coconut.
Using current mechanistic interpretability tools is a blog post by a bunch of people, including Neel, Conmy, John Engels, a bunch of famous Mech Interp people. Although, yeah, okay, it seems like it is mainly Bartosz and Bart Bussmann, and the other people are, just supervisors. So this is, I would guess this is maybe like a maths thing or something like that.
Later they write
it on the research sprint. It wasn't really necessarily maths.
Okay. We study a simple latent reasoning on math tasks using standard mechanistic interpretability techniques. Okay, so they are using this Cody, compression into continuous space instead of destination. I don't know, I haven't even seen this paper, so I'm not sure how this Cody thing works. Maybe Relber knows and can explain it.
Yes, if you look at the post, they explain a little better. If you scroll down after the intro, you see the Cody system where they do his teacher and student model task. So this is the same exact model. Go scroll down.
Okay,
experimental setup, you see Cody, student tasks, and self-installation. So they talk about how they, and if you go to the Cody paper, it does show a diagram. Let me get.
I'll
Oh, that
wait.
yeah. It
Maybe
shows
also zoom a
the
bit.
example of like the student and the teacher task teaching each other.
Oh, coconut, yeah.
Yeah, it's not exactly coconut. It's slightly different because coconut it's just a
I
different.
see.
The difference was Cody, unlike coconut, had better performance and was able to match provide fine tuning for math.
But like, how does it work? Like exactly?
Yeah.
Does it?
Maybe.
Let me get
Oh,
up
go
the
ahead.
image right now. Let me show you the image. Where it's talking about. Where they feel.
I know the latent models or some of them, but yeah, this might be slightly different.
Yeah. Let me get it up. It uses the normal chain of thought to train it actually. Let me get up
So
the
like
image.
you have a model that just does normal chain of thought, and then you.
Yeah, this is like the teacher model. This is like the explicit teacher model. Yeah, it's this image. Let me screen share. This image.
Yeah.
So you have the normal teacher model. You train this with normal COT, right?
I'll put your thing on this stream for a moment. Okay. Yeah.
The Z's are just the examples of instead of using tokens, they use the hidden state and just pass it into itself again.
So the last hidden state, you pass it again.
Yeah, they try training. They basically try training the latent Cody model after doing the latent COT to have output that matches the explicit chain of thought.
Okay, so
let's go step by step because I'm not sure I understand it.
Yeah. So like so the first table is in the latent models. When you're doing the autoregression, basically you could say, you skip the unembedding step and the embedding step, and you just loop over the layers recurrently, basically. That's what I know about latent models, and this seems to be the case with the first student model. So it's
Yeah, but they found for this paper they found that different amounts of times looping the model has different performances, and 5 and 6 seem to be the sweet spot. They go over this later on in the.
Okay, and so maybe let's read the latent. Let's read the last wrong post, and they try to explain.
Yeah. So they train the teacher and student model are both done inside the exact same model actually.
Okay,
they're just different modes. They're like different modes. You can see like prompt EOT and prompt BCOT. So you're able to do both of this in the same model.
There can't verbalize shit. Okay, let's probably read it step by step. I think we're jumping way too much.
Okay.
Do we need, in order to understand the last wrong post, do we need to read the Codely paper and or will they explain it in the last wrong post? Okay, so let's just read the.
I found it more interesting how they tried interpreting the Cody paper.
Okay,
Cody
and if he gets stuck, we can just go to the Cody paper or for instance.
Okay, I guess I'll switch the thing to my stream. So yeah, let's read this one. We can. Yeah, I think don't think I understand how the setup of the coding model works, but maybe that we'll figure it out. Okay, so yeah, today's performance are latent models. Latent reasons will increase attention in this approach. So scenarios. Yeah.
Have you read the results in the TLDR? Okay.
Oh yeah, sorry, I skipped it. Let's see the results. We find that the model solves math problems requiring the 3 reasoning steps by storing the 2 intermediate values in specific latent vectors. The third step is yeah. The logic lens shows that intermediate calculation represented the receiving string to be latent reasoning. Aha. The latent verbs are not perfectly interpretable with the logic lens, but through patching we demonstrate the story intermediate calculations. I think you remember you said it does look more interpretable in the tool lens, right?
Oh yeah, that's my own thing. That was like my own extension I did. I also did linear probes on the model too, and investigative linear probes.
Patching has no effect in model accuracy but applied to problems with the same intermediate value, and at the same time change the answer with anticipated while on problems with the intermediate value. Alright, makes sense. No, patching where? I guess I'll say it later. We believe that the correlated motion model is a reasonable user preview as it's trained to have relativity wake natural language prior insulated method. Our findings suggest that applying a interpretative to related motion models is promising. We still make have more component models studying border tasks. Today, it's best performing LLMs are reasoning models. Single thought has consisting of tokens in natural language. However, latent reasoning is gaining increasing attention. Latent reasoning is likely to have significant performance benefits as precursors to store so much more information than tests. How reasoning process it performs.
It allows it to track the state. Interesting. Intermediate values in specific latent vectors. I kind of want to mention one thing. Mamba are becoming much more common in open source models. There should be more interpretability on that. Yeah, anyway, let's continue.
Teacher tasks. The model learns to generate a natural language COT followed by the answer, using standard cross entropy laws. Reasoning trees generated by smarter models such as GPT-4o. Given tasks. I think the expansion, so latent methods propose and the supervision. The linear code will complex method as a no. Implicit benefits from exposure to the reasoning trace and training. This is an advantage that study no COT based acts. Therefore, any problem stem from this training rather than the actual usage of the latent methods. This is the specific contributions of the latent methods. A proper biases should share the same training benefits. To that end, we train a single model that can operate in 3 modes. Okay, yeah, so using special control tokens, end of text, variable affinity. Okay. The correlated. Yeah, so they have a model that. Okay, let me read this. So, so you have the model interesting on 3 tasks. First, the language, natural language COT, which is natural language COT followed by the answer using standard and cross entropy laws and reasoning traces. Aha. Yes. So there's this still in GPT-4o.
So the teacher task natural language COT, that's just classic llama model. And okay.
The Cody paper are like there's variants currently. The only ones are the Llama 1B and the GPT-ish model.
Mm-hmm. Also, I've seen some Reddit posts recently completely grilling the Coconuts paper, but yeah, I'm not sure if it was actually grilling correctly. The Coconuts paper, which is original latent.
Yeah, I might have complaints about the Cody paper. It's not as good as initially thought.
Yeah, I've seen similar complaints with the Coconut.
No, it's because if you try putting the Cody model from the setup from this experiment, if you look at the training setup for this model, if you see down there, they try. If you look at how they tried training the model to not have the final be able to just tell based on the prompt. It's like we ablate representations of specific numbers. That part.
Like even if there are like issues with these current latent models, I think like they will emerge eventually to be better.
No, but like so, if we ablate a representation specific numbers. I think this is what caused the Cody model for this one to have catastrophic forgetting. This is my assumption, because if you try prompting it for anything that's not a number, it says the result is blank. It literally outputs a number, even if you put in a non-number based question. But its accuracy for numbers is legit and shows the work. So yeah, maybe this kind of prevented the model from learning anything but numbers.
Okay, so here they took the Llama model and they turned it into a latent model by looping all the layers. Interesting. Like, there was also another paper you messaged about me Rambert on the Yannick server, which was instead of looping all the layers, which I think is happening here, they looped like different like from layer 5 to layer 7, for example.
Yeah.
And it seems like for math tasks specifically, there is some kind of subset of the network which if you loop like something like layer 5 to layer 7 like 3 times or something like that, that's when you get the biggest math gains, which would as far as I understand imply that part of the network is mostly correlated with math circuits or features or whatever, and with some composable reasoning, since you can do this or something like that.
Yeah, I didn't understand the Yannick paper the best. I need to read it a little more to implement it, and also just
super
to make
cool.
Sure.
The guy basically took this latent idea and he looped like different parts of the network, like started from some layer to some layer, and then tried this whole state space basically, like from Y to J. He just iterated over all possible Ys and Js, which is super cool. I'm gonna someone is reading it. I'm gonna post it. It was very viral. Let me find it real quick. Yeah, so this that's also
yeah, I might need to look into this latent reasoning model.
But the latent reasoning models mostly trained from scratch, but here they use the Llama. Okay. Yeah, I still don't understand the setup fully, since there is some self-distillation stuff happening. I've read a self-distillation paper. I wonder if... Okay, whatever. Let's read it. I'm jumping to another paper.
Okay, going back to... Let's go further. Okay, so they have a Llama model. They train it on 3 tasks. First task is just natural language using structures on reason iteration. So this is just doing distillation on GPT-4o.
Okay.
Second task is rather than use discrete tokens, the model is trained to provide the correct answer after reasoning in a sequence of 6 continuous latent methods. But
why are they using non-reasoning model to generate a reasoning tree? Oh, wait, I guess yeah, you can do that. Still weird. Okay, but it's an older thing, I think. December 2025. Maybe they did it a longer time ago.
Okay. So ranging up between natural language isn't for a while reasoning model though.
No.
Okay.
Oh, well, actually, when I remember when it before GPT-5 came out, like few months, it started to do reasoning. So I think they started to make it a reasoning model at the end. So yeah, maybe it has like 10,000 different.
Is this really a latent reasoning model?
Not latent, just reasoning, just GRPO on pure auto-regression. Oh, yeah, it doesn't exist yet. That we're going over right now. Yeah, I'm gonna post it.
Okay.
This one.
Thank you.
Oh, it's
I
on the
posted it in
on Discord event, by the way. Like if you click on the Discord event, you can see the thing.
Sorry if I started talking too much or too fast. I just took coffee and I just realized my brain. Whatever. Let's go. Let's read.
It's okay. Also, yeah, don't worry. It asks things or interrupt us. Don't. I mean, for the other people. Yeah. This doesn't have to be the Victor Randberg and Bernie podcast.
Yeah.
Rambert is also talking. So
yeah.
Now it's a third podcast, third three people podcast.
No, I'm the occasional member. I'm the guest speaker that rarely
You're
talks.
slowly and slowly becoming same amount. My English is failing. Whatever. Let's continue.
Oh yeah. If you look at let's go back to the Scratchpad. Let me just give I guess like since I read it before, I could tell like what the important parts are. So the important parts are like for this one, like similar to the original paper, they use the GSM8K and the Common Sense QA datasets. And then over here you can see how they did the different prompt modes. So this is all the same model. They say over here like to assume like there's no like uplift from the supervised fine tuning. They like trained one model to do all this. Like you see after the question, it talks about that.
Yeah. But before that, what's the self-distillation step to bridge the gap between
the self-distillation step?
And latent theory code is trained to align the final hidden states when reasoning in these two modalities by minimizing the L1 distance between the representation at the answer generation step and the.
Remember the diagram I showed you earlier? That they're just trying to get the student-teacher model to be lower distance.
Okay, yeah. So they have in this case, the teacher task is just the model trained to copy GPT-4o reasoning, and the student task is the model just trained with reinforcement learning to have, well, not reinforcement learning, actually can be gross entropy too, but with to just have the. You can call that reinforcement learning.
They just use a loss function. They just use KL.verbase, and then they basically try matching. So they have the latent reasoning already. So they just like feed in the latent model multiple times inside of the. So while they're using the latent reasoning, it's inside the. You see the latent COT. You see the latent token, the BOT. You see inside the COT token. No, for the last round post, you see they're set up for how they did inside the.
Yeah, so they just have the last. They take the last layer and they try to make it closer.
Yeah,
to
the last. Yeah, they only care about the last latent token.
Okay, makes sense.
Yeah, and they show how it works on most datasets. This Cody models suck outside of math for some reason. Or this Cody model specifically. I need to investigate more. I think it only puts the answer is number. Like it says like for example, like for one of the things I did was like I tried looking at the output for the model for like what animals fly, and it outputted like the number like 24 or something.
I'm confused by so I guess this is a way people might do this, but you could also imagine, right? Like not people training models in a different way when they don't do this self-distillation steps, and the model just learns. Like the people just find a way to put latents on the they just put latents on the chain of thought, and they train the models with reinforcement learning, and I don't know much this will generalize to that kind of thing. Also, someone posted on chat.
GSM8K dataset shows the steps, like the full steps that hypothetically would occur, and the
Also para Briarius or however your name is pronounced, sorry, it says, doesn't seem clear, but I'm curious to see how they label the GSM8.
Oh, how they labeled the dataset. I don't know. It just
It
saw that the dataset existed. Or no, there's
doesn't-
multiple GSM8K datasets actually. There's the
it
original
has
one.
an answer already.
Yeah, there's a
right?
labeled version of the dataset. There's a labeled version of the dataset.
Like if you have the correct answer, for the reasoning, they just copy the reasoning of.
They just copied it from the
GPT-4
teacher model. They used the teacher model.
When
Yeah,
they
but
say
the teacher model is trained to copy GPT-4.
So, yeah, they just
when they say
yeah.
Yeah, like when they say in a sequence of 6 continuous latent vectors.
Yeah.
I need to check the paper to understand what do you mean.
This is literally just the hidden state layer, a hidden state part.
So they just output
go ahead.
6 times, like yeah.
So they basically do embedding all the layers, skip unembedding, do all the layers again 6 times, and then unembedding after 6
Yeah,
times.
and they also try different amounts of latent steps for Cody, and you can see down here, like they show the performance gains between the different parts. That's
so they first do the distillation. Is it all of this sequential, all these different steps, or they first do the
latent steps are all sequential? So the latent step 1 is done after before latent step 2.
I mean, so first you do the teacher task, or they say jointly on 3 tasks. Do they?
They train it on the different things.
Do they train on? They do all of this at the same time, or do they first do the distillation from GPT-4, then do the latent vectors training, and then do self-distillation? Wait, let's see. To bridge the gap between align the final hidden state when the reasoning in these 2 modalities. Oh.
But one question is like, so they're just skipping the unembedding step, right, for the student model? But like in the usual autoregressive model, like we sample the next token. So how are they like getting the next latent vector?
Oh, but they don't train it on that, right? They only train it on in the latent thing. They only train it on the last answer, right?
No, but it's still autoregressive.
Let me show how it looks like in the code, so you guys can see.
I think like when you look at the when you look at the diagram, you see that it out.
Here's how it's implemented in the actual code.
The dimensions of the
vector. You see how they unsqueeze the hidden layer, and then they add the projection optional, and they just continue to do. They just put in the. They just made it so that the model accepts the latent embedding as the input.
Yeah.
And then they continue like use the pass key values, and this is how they output another latent. This is just for the logic.
The output from the last layer is just put again to the first layer.
Yeah. You can see
and it's interesting how you can do this and it works.
Yeah, well, no. They trained
and it's interesting how you can do this only with some layers, and it's like that you can loop only part of like only some layers.
I assume you take the output of the last layer on the last token, right?
Yeah, they only train on the last token for the latent token for this.
Yeah, so like, I mean, I assume you take the output on the last token and you input it at the end.
Yeah, you only output the last token. They don't really output the intermediate tokens, so that's why you had to use tools like LogitLens to see what they're actually outputting.
But I mean, they're still generating like 6 latent vectors, like autoregressively.
Yes.
Yes.
Mm-hmm.
But
they try different amounts of latent vectors too.
So are they using like an MLP to like get the next latent vector from the current latent vector?
No, like the model gets input it's like a normal transformer model, right? You input some sequence and it outputs some other sequence, and in this case, it just, you take whatever it outputs on the last token and you put it on the input.
Oh, so it's not autoregressive. It's not autoregressive.
It is autoregressive. Like it is autoregressive, but it's or like I'm not sure what you mean with autoregressive. It is autoregressive in the sense that it has a diagonal on the attention,
Like,
so all things come.
I guess depends how you define autoregression.
No, so like you get the first latent vector, right, from the prompt. Then you get the second. To get the second
that's latent
latent
0. That's not considered a latent vector. That's considered a normal vector. That'd be considered latent 0.
No, I think I know
there's
what he means. Yeah, you get the first one from the prompt, yeah, because like the prompt and at the last token you get the first one, and then you input the first latent vector and you get the second latent vector on the second.
In the paper, there's a different diagram. If you go down, that might show it better. Go down.
I thought I showed that. Yeah, that was the diagram I showed.
Yeah. Here you can see that a Z1 goes at the bottom again, basically. So it's, I don't know, latent autoregression. Wait, this is the COT
latent
student.
autoregression.
Yeah.
So you're just skipping the unembedding.
Yeah. Technically, you can skip also some layers, which is done in the Yannick's paper. Not Yannick's, the other paper.
So
and
it's
that's
like the
better.
normal process is just instead of outputting a word, you output the thing without the embedding. Yeah.
Yeah, makes sense.
And the problem is that obviously you can't train that normally, but you can train it with on the last word and do the same kind of thing as when they do RL or whatever.
Wait, so when they do the aligning, they minimize L1 distance between the representations at the answer generation step. Cross-entropy loss between answer and the chain of thought. So they take the okay. So they take the chain of the symbol, the normal autoregressive chain of thought. Then they take the latent chain of thought, and then they just minimize distance between
they try to make
they only minimize not the latent chain of thought itself. They only minimize the output of the last latent.
Yeah. Like they try to make the output like the last hidden state to make it the same. Yeah.
So you take what is before the unembedding for the natural language chain of thought, and then you take the latent chain of thought, and then you minimize the L1 distance between them.
Yeah.
The thing is, if you are doing that, it makes sense that you will get that things like the logit lens will work, right? Because it should be the same as the unembedded, as the thing that doesn't applying the embedding should get you the word if it was the same. So the logit lens should literally, if you are doing this right, it should just work, right? And I feel like this is kind of meh in that actual models. Yeah, the thing is, sorry, robot on the chat is correct. So isn't it, if you are doing this, isn't this trivial that the logit lens will tell you like the same thing as if you had done the other? I guess not completely, because you are also training on this, right? So it might, and depending on the order, and this might move it away a bit from that.
And you should also look at how they specifically remove certain numbers during the training.
Okay. But also, apart from that, I feel like the actual hard thing is going to be interpret models that have this kind of are doing this kind of thing, but they don't have the self-initiation step.
This is aligning it with tokens that we can read.
But yeah, like we don't have a method to make like I can't think of an idea to do it that there's existing where latent reasoning was made without like a self-distillation step.
Yeah,
that works good.
The
latent reasoning models currently do worse than normal CRT though.
The original Coconut paper isn't using any alignment, no?
Yeah, but it's doing worse. Like they were trying to make a latent reasoning setup that does matches normal.
Yeah, I've seen the roasts of the Coconut
the difference
paper.
between Coconut and this one is the performance for this one is better.
Okay, I see. Yeah, it makes it's being aligned with like what works.
Yeah, so yeah,
this
is the best-ish out of the latent reasoning for math, at least.
This is kind of a hybrid in a way.
Yeah, you can.
I mean,
it's not really.
Like it is kind of means it's not like the latent listening doesn't work, or the current
like it
makes don't work. They just
like
work
for me,
by copying the normal reasoning.
Like for me, it makes sense that it would kind of diverge.
I expect that you get something where you train the models with more informal learning and some latent reasoning, and then it starts doing weird things on the latent reasoning that are not, the main chain of thought thing. Maybe you need it to initialize it. It's better to initialize it with the some kind of self-distillation step, just because of the same kind of reasons why pre-training models sometimes works. But I don't know. It feels like this should be possible to at some point we're going to have models that are using the lates in ways that are just copying what you will do on text, and we kind of need to figure out techniques that work for that. But anyway, let's keep moving.
There are also like some architectures that track some latent variables, which might also be interpretable. I'm kind of still surprised that there's not more of these latent things when there have been so many experiments, but it seems to not work in practice as much.
In principle, benefits from exposure to relation interest during training. No,
This is just the TLDR, how they use the exact same
we
model.
train a model completely 3 models. Yeah, so they have the models. Special control talk. Yeah, so they have the model that does the 3 things. Direct answer. So it does this and verbalized theo thought. So wait.
So when they
it's kind of the same, right? Better in some things and worse. Like the latent theory doesn't seem to help much, right?
Yeah, but it didn't have as much of a decrease as compared to Coconut.
Okay, but like, is there a point on this kind of the thing? I feel like it's just learning. Like if you're doing this setup, it's just learning to imitate the.
Maybe it's learning to imitate. Yeah, it might be learning.
The verbalized theory and the latent part doesn't really do anything.
The neuroanatomy paper, which instead duplicated just some layers, topped open source benchmarks. So you can do
but
better.
That seems like it's okay.
But you have to find which layers to loop, which layers include math circuits or whatever is actually happening. That actually gives you gains. And also, I think this guy didn't train it. I think he just basically find a good layers to loop, so you could additionally train it more.
That seems
in other paper.
Extremely hacky that it works.
It's extremely hacky, and it's extremely confusing to me. Well, maybe not. That's when I think about in retrospect, because there's like, if you loop some layers, they are more correlated with better performance on like IQ benchmarks, you could say. And if you loop other inverse layers, you get almost inverse. You get in performance increase on AQ, like not EQ.
It feels
IQ,
like
but
that
AQ.
depends on that's like going to depend a lot of details on how the layers actually work.
Yeah, it's different for different models, which is fascinating. And you can like do heat maps, and you see different patterns there, which is what the hell.
Yeah. I could have expected also things to break, but
yeah, that also happens.
Yeah, but I feel like there is no good paper on actually any good to do actual latent reasoning. Like where
well, it hasn't existed yet. If it did exist, we'd be having latent reasoning models already.
Yeah.
Yeah.
There's you guys are complaining about there being
papers.
no good latent reasoning paper. If there was a good latent reasoning paper, the AI companies would be already using latent reasoning.
Yeah, it just it seems clear to me. Maybe they say something about this. It seems clear to me that methods tested on this code stuff will actually work on the whatever real latent.
I'm gonna go try it on Coconut. I'm gonna go try seeing if I can interpret Coconut with similar methods I used on this.
I mean, Coconut also seems like it maybe just doesn't work. So
yeah, if it doesn't work, I could just say it doesn't work. I'm right now looking.
Yeah, so like you test it and it seems like gibberish because it's not actually giving any. I don't know how bad it is.
If it doesn't work, if it depends on the exact setup, then we're screwed because the new latent reasoning model could just break everything. Maybe there's some things that work.
Yeah, I don't think we will converge to literally imitating non-latent.
Yeah, but this is one of the setups.
For example, if they use if they are using the logit lens, like obviously the self-distillation makes the logit lens work because it's literally making it more similar to a thing that is supposed to be passed through the embedding to get the word.
Like if you do this kind of like basically imitation, do you get the gains of like neuralese? Basically, I don't think you do.
I mean, you don't, because you get the same accuracy on all of the data sets.
So this makes it basically the same, I think, because like almost
like it's slightly better than one, but that seems like it could be random, right?
Yeah, you basically become the original model this way.
I mean, they do train a bit on the student tasks. Like training on the student tasks might change things a bit.
Maybe if you just do that, then you just crash or something. So you need to like ground it back with something that actually works.
I mean, maybe it's if you change the ratios, maybe it works the same way that you train models with reinforcement learning, but you do scale the divergence with the original thing.
You mean like the self-verifying and stuff like this?
I mean more like people also try to not change the models. I feel like you could use this as a term of the loss, but still train on the with the student or with some reinforcement learning and try to keep it closer to the original thing, but it.
They don't do reinforcement learning here, right?
It's probably a bad method because this method wants to have literally the same embedding, right? And maybe you want something more like the same kind of reasoning or something, so you probably just do something about the thing.
In the discussion. Yeah, like in the discussion, they say that models trained via pure reinforcement learning without a verbalized teacher may develop more alien representations, rendering technique like logit lens less effective.
So maybe the self-distillation step is just the reason why it works.
Okay, let's actually read the thing instead of talking so much about the speculation. Evaluation prompts. In experiments, we use math programs similar to this one. Yeah. Reasoning steps to solve. This is multiple evaluation prompts. I don't know how they do this. Maybe it's labeled on the original thing, or maybe they have to manually find them, or ask a model to find problems that require 3 steps. But yeah, we use 20. Oh, wait. What was this data set, by the way?
It's a bunch of math questions.
Okay. So maybe you can easily find math questions like
grade school math. That's what it means. The grade school
okay. So
abbreviation.
it's probably easy to get automatically which ones.
And it's from OpenAI. Yeah.
And in the arithmetic, it's same thing. If you are doing arithmetic by doing, carry, add and carry or whatever, and the kind of thing, you can just check the number of digits or something. That filled with numbers ranging from 1 to 10. Total, we present the result for 1,000 prompts. Sorry, makes sense. A team starts with 7 example. A team starts with X number members. They recruit Y members. Then the current member recruits C additional people. How many people are now on the team? Give the answer only and nothing else. Okay. How many latent vectors does the model actually use? To determine whether the model uses all of its latent vectors and to identify vectors we can target to interpretability study, we compare accuracy across different numbers of latent chain of thought iterations. How many vectors can use chain of thought before receiving an end of thinking token? Okay. Okay,
Yeah, the greatest increase is from latents 5.
So the things require 3 reasonable steps, but seems like doing 5 latent steps does help. Probably because the reasoning steps require more than 1 token to do. So yeah.
Yeah, it would make sense that for different. So this is equivalent to doing 6 chain of thoughts. I think there should be like.
They
should be trainable.
Do the solutions actually like does the student the teacher model actually just use 6 tokens to solve this?
No, there's more steps than latent reasoning vectors usually.
But
no, there's less steps. There's less steps.
I think in the problem they say that they only really need 5 steps, and even of those 5 steps, of those 5 latent reasoning vectors that are generated, they only basically use 2.
Here's the reasoning steps to solve. Yeah, but like so requires that much steps, but on the okay. So for example, reasoning sure will look like but this will be multiple tokens, right?
Yeah, each of those numbers would be considered tokens, so that'd be a lot more tokens than simply just using 6 latent reasoning steps.
When but you need to then to match to do the self-distillation thing. Okay, so
yeah, you should look at maybe the next step about looking at the probabilities for 2 and 4 they found. Next section.
okay, we compare. I guess maybe that will be explained later. We showed the American records increasing accuracy at the 5th latent interaction, which might indicate that the model uses less 5 for the first 4 latent vectors. The infinite iteration appears unnecessary as not improve accuracy. Okay, so the 6th one actually does really get salary. We expect reasoning should look like this, but what does the reasoning actually look like? That's from the visualize.
They apparently extract the intermediate steps. They say. Using
Yeah, I mean, here they do the Luigi lens, right? But I'm curious about the actual verbalized single thought one. Like, does it says should look like this, but how does it actually look like? Because I'm confused about why it actually does, like, it's so, like, could actually output for the other thing. But, okay.
Oh, this makes me think, like, sometimes the actual chain of thought is different from if you pass it through unembedding. I wonder when logit_lens here just gives you something wrong compared to what's actually happening, because unembedding isn't good.
What I kind of found interesting about the tuned logit_lens is if you only train the logit_lens on latent activations for like latent 5, or the odd ones, it has different different like outputs. Like for latent 5 only, it seems to like output a lot of the word therefore. And if you use like top K percentages, you could actually see the percentage of therefore in top K only appear after latents 3.
It makes sense if the model, the original model, normally says therefore on latent 5 and tries to put all of the stuff there to next.
Yeah, but that's a noticeable difference that I was able to find with the top K, and also was able to find with like probes.
When the plot one probability of the last layer of step 1, step 2, resolution trends. This do not increase a step in which the model produces the final answer.
Oh yeah, the linear probes for final answer mission were the highest layers, latents 2 and 4.
So the Cody model had wrong baselines. Nice.
Yeah, the mission
and
had
not nice. Oh well.
It's nice for this post and less nice for the coding post.
They're like, let's interpret latent reasoning paper. Oh well, this paper is terrible. Let's actually make it better and then do the actual interpretability. Nice. Good job.
Nobody has made the good latent reasoning model yet to do interp, but like, might as well do interp on the bad latent reasoning models, and then maybe some of them could transfer over to the good ones when it comes out.
Yeah, like.
Oh yeah, if you look at the entropy spikes at the odd latents for some reason. Or this is not in the less strong post, it's just my own experiments.
Probability of intermediate values is very high even when model assessing correctly. The same model represents interpreted results in these two latent versions. Okay. I suggested but not causal. Someone left. Logic lens is usually for the causal. We don't know that the percentage actually makes for the model. When we write the original latent vectors with the vectors from different problems, we how this represents. Okay, so they have numbers.
Oh yeah, the ones that were able to be patched with random vectors were the ones that had high therefore rates in the top K, and also like the logit_lens showing therefore when you tune in on that. That is separate from this. That is just what I found.
Sorry, just to be clear, so you like replicated this less wrong paper basically, or like this less wrong block?
No, I didn't replicate the paper only. I also did my own experiments on top of the paper.
I see.
Yeah, so I just did some things, and those were some of the findings I found, which kind of might explain.
I think that's interesting, but okay, let me try to understand
So,
that.
the therefore tokens,
Like, it
This
could be
one-
capital therefore, or it could be lowercase therefore. Like, it appears in the top K or the logit lens if you only
Wait.
train it on latents 5 or like
Okay.
6.
So the most probable tokens will still be the intermediate state, but then all of the tokens after that will be like therefore.
Or like, no, if you train tune logit lens, like the reason why I looked into this was when I trained tune logit lens on like different latent setups. I found that like training it on like different number latents, like latents 5, that logit lens only shows like the word therefore for like basically most of the logit lens.
Oh, I see. So it's like
And
saturation.
then afterwards, I went from there to look into the
Hmm.
top K rates, and I found the top K rates spiked for the words therefore at 5 and 6. So I thought maybe that might. But no, but the top K has 0 therefores, even at like top K 20 for latents 3 and before. It only appears at latents 4 and 5, 5, 6, but spikes at 5 and 6. 5, 6 has higher, but that was one of the findings I found. Yeah.
I have more issues with the baseline here though when they do the evaluation. If I get it correctly, the direct answer.
So I'm right now trying to do like patching to see if therefore is actually the difference between latents 3 and 5. Because I feel like both 3 and 5 are both a type of latent that has a lot of the computation from the high entropies values. Oh, this is separate.
I mean, the fact that the 5th and 6th tokens just have mostly therefores, isn't that kind of a sign that there's probably not a lot of processing that's occurring once you, exit past those
Yeah, but
tokens?
I'm still doing testing on them. I'm just right now confirming the assumption. Though those are like
Well,
some unique properties.
I
What are
think
you
it's not. Oh, sorry. I
Like,
mean, so. Oh.
Are you
Talk first.
patching the- Oh, sorry.
No, talk first.
No, I was just gonna say, like, what are you patching with the therefore tokens? Like, are you just doing similar to them, like different types of mean averaging across different types of answers, but using like tokens 5 and 6 that are just therefores?
Or no, this is just like separate experiments I did with the logit lens and like looking at top K that like was found unique, different. That were like those were the things that showed like different things about 5 and 6. I still haven't tested removing like therefore from the model latency 5 and 6 and see if like maybe this fixes it.
Well,
But
yeah.
I'm gonna try that later.
So when you say that though, I'm still a little bit confused as to like what you're specifically patching. Like, what are you patching with? What are you planning on
Or
patching?
I
with
still
the
haven't set this up yet. This is like still like this is like to be due in to be continued.
Yeah, okay, thank you. Not trying to
But like the 5 and 6 having a lot of therefores in the top K, and also like the fact if you train tune logit lens on them, only 5 and 6 is kind of interesting. That's what I found interesting.
Yeah, no, that
I
is
think.
interesting.
So you said earlier that that might mean it's not doing a lot of processing. I think it's not doesn't necessarily mean that. I mean, it could actually do all of the process on the thing. Like the therefore means that it normally like if it was not the latent model thing, it will write therefore on that step. But it could be doing all of the computations for that there because after the therefore it has to actually output the answer, right?
So maybe
So-
the therefore, like the prevalence of therefore is the sign that the model has the answer at that token or at that
Yeah,
line.
but it could have calculated that at previous layers on step 5, and it kind of seems to be right.
Latent
because on
4
step
was the
5
first latent where latent therefore appeared, but it was at a very low rate, and then 5 and 6 were when it actually went higher. I could show the graph later, but
Yeah, so that means it on 5 it has like also to see the accuracy on 5 it has the answer. So it's then the model outputs therefore, and then on the next step it outputs the actual number. But
yeah.
it seems like it calculates on 5 because you try to output on 4, like after 4.
Or some of the questions has
accuracy.
therefore, but like across the entire data set, 5 and 6 is where it spikes. Like for like I guess like some cases maybe like it appears earlier, but
So that sounds to me like it actually ends the ends the calculation on the earlier layers of step 5, right?
it could be
and
between
then,
4 and 5 maybe.
Yeah, between 4 and 5, and then
But it never therefore never appeared on latents 3, 0, 1, and 0. never appeared there. So I'm assuming those three are important.
Yeah. Interesting.
Or that was
like,
my own
this is-
finding. This
yeah.
is this was just I couldn't post the less strong post because it keeps on giving batch index 0 errors. They can't even finish.
Batch index 0 errors.
Also,
Less strong post just does not want to send it. Post is technical issues on my less strong.
Oh.
Overwrite is
Yeah,
the original.
Like, this makes me think that if this is correct, that it ended on like layer 4 or something, then like hard coding the number of layers like this is wrong. Like, we also don't hard code how many chains of thought you do in verbal. Like, the models infer how long they should do chain of thought for. So I think there will be some way to like do.
I mean,
recurrent steps.
It will be easy. You just get the model to output the end of thinking token.
Mm-hmm. Yeah. That's good. I think so. Or like some classifier or something. That's basically the thinking token. Yeah. I mean, end of thinking token or something like that.
Yeah. So.
Oh yeah. It could be 0000 or something. Like
yeah, here was on the Google
whatever.
Doc. This was like the therefore tokens. I tried it across like the different tune lenses. Like you see, like it only appears after 3. The only exceptions are like the latents where I trained it on latents like 5 and 6. Tune lens where it did like 5 and 6. You can see like 0, like basically 0, therefore is around 3 across the whole data set. And then 4 a little bit, and then 5 and 6 is where it actually appears.
Mm-hmm.
Yeah, and also what I found interesting, if you look at the results for the scratch, like the less strong post here for like 2 and 4, if you, I tried training a linear probe to train like binary classifier between intermediate and final answer mission, and the probe activated highly on layers 2 and 4, latents 2 and 4, so that kind of matches the results here. It's the one above the graph, the figure above this one. Victor's the figure above that one.
Oh yeah, sorry, I was reading this.
Yeah, that was the one the linear probes matched. And also final answer emission also across top K also matches this pattern.
Okay, yeah, so they also patch with they patch with random with intermediate values, and they seem that it does changes the answer. And if you train patch with things that where the intermediate value is the same, but the step is the thing, it doesn't change.
So they like ablate, for instance, latent vector corresponding to like 3 in a multi-step calculation, something like that, and that changes the performance drastically.
Yeah, and if you have a later step that like it's from a different calculation, but where the first step is the same, you still get the same answer, which does mean it seems to be the intermediate values. And they say it's on the third and the fifth latent. So that means on the fifth latent where you also see the therefore step model is also doing the second step.
Like sometimes
so
on dummy tokens,
part, it does.
Yeah.
This is how the entropy looks like for the model across layers, but you could clearly see how at the very end, like latents 3 and 5 are consistently the highest, with latents, the odd latents always having higher entropy. That was interesting.
What did you say? Can you say it again?
I tried looking at the entropy of the model, like using the entropy calculations to see if and then I found the latents 3 and 5 were the highest, with latent 1 being latents 1, 3, and 5 all having high entropy, while the even ones having consistently low entropy, like they seem to be grouped.
Interesting.
Also, okay, so you patch with other numbers on the other positions that are not 3 and 5, it usually doesn't change accuracy. If you patch with a random net vector, it does, which makes sense. That just will break a lot of things. It breaks whatever the model uses to know this is a high school, grade school make math question or whatever.
You're almost done with the post. Like the rest of it is not as interesting. But
yeah. We are trying strong areas the intermediate values are stored in latent vectors, but the model sensors. We conduct the experiment. We were with the fifth later version. Observe whether this changes the model in step 1. Okay. So they take the fifth one and see if that compute average latent vectors with the specific step 2 values.
Interesting that they do mostly arithmetic. I wonder if they did like some more abstract reasoning. But yeah, it's very small llama model, so.
So they have the standard sampling without patching. Yeah, the patch.
Oh, and they also trained it to always use 6 iterations. So like when they compare the different latent reasoning iterations, 5 isn't optimal because that's like emergently optimal or something like that. That's optimal because they literally trained it to do that amount of latent reasoning steps. Okay. And also it's on a data that like it's on data sets that are literally like about these 6 latent reasoning steps. So like if you had a data set that would require a lot of chain of thoughts tokens, then I would I think that's why. Yeah, then that would like have much more variable length. This doesn't seem to be really general in this sense.
I mean, you could check which ones actually matter, right? There's a lot of steps. And first, you can see. I mean, you can see how big it is. Like you just let it do a lot of steps and see which one was. But also, even if it's not always on the same one, you can do something where you test different positions and see what happens. But yeah.
Like the issue is that they train explicitly in the training. They train it on the 6 steps. Did they? And
for all this analysis only on latent 6.
I'm surprised I guess maybe they tell it to, but I'm surprised that does GPT-4 really do it in 4 steps? I guess you can tell it to generate 4 steps or something like that. Because otherwise it will write some very long text with a lot of tokens.
Like the types of questions they give it, I'm not surprised that around 6 steps are on average. I think what they did is that they sampled this, then just averaged it and was like 6 steps.
No, but I mean they probably need to do something like, okay, so I think even if you ask a very dumb question to GPT-4o, I think it's going to write a lot of text for it.
Oh, right, okay.
You know what I mean?
Yeah.
Maybe really just ask it, answer this question in 6, in 6 steps. Or
yeah. Like this seems, I think latent architectures will be good because they will, in a similar way how current chain of thought that's not latent, like the models think or they just infer if reason for no tokens or a reason for like 10 minutes or something. So
yeah.
like actual latent architectures will adapt basically in this sense.
So, what's the difference here between original correct and match expected? Wait, what original correct? What? So because the red is patch, what? So feels like the intervention patterns with a vector average over prompts with the same template. About the frequency of the original
Fifth plate. standard sampling without patching. And which will pronounce with the same. Oh, okay. Make all layers at the 5th position.
Okay, so it doesn't work that much. I still don't completely understand this diagram, like what's this and what's this. But okay. But they say the patching doesn't change the answer in the way they expect that much. Which is also not that good, I guess.
What? I'm confused. What is standard sampling without patching, and why is the frequency changing?
Yeah,
Wait.
that's I'm
What is happening?
really confused about that too, because the red color says it's patch, and they say for each patch we plot the frequency of the original correct answer, then the answer is expected the patch in the step 2 value.
Why do they have exact opposite findings from expected findings? Huh? What? For all patching, rate at which model outputs the expected answer is higher? This makes zero
It's higher
sense.
than... Okay.
Am I
It's
misunderstanding
higher than
something?
random. Like, it's higher than the other possible answers, I guess. Not that the correct answer, I guess. Like, if you patch with a different number, and if their patching method to do what they were expected, it will change the answer to something else, right? Like, they change the step 2, so it should make the answer some specific number, and they don't get that, but they get it a bit more than random. I mean, they say it's not a, it's a very certain. We modify only latent better with promise that still points to the original answer, but But I still don't understand what the original correct thing is. It's different. Like, what are they doing on this red thing that is different from this thing that is not patching, because patching they get this thing, right?
I think I'm misunderstanding something. If you only do like standard sampling, then like frequency 0.5 that you get expected answer is... Oh, okay. Huh? The frequency of correct expected answer is like 0.5. And if you do the patching, then the frequency goes down to 0.3 for all the different patching. Right?
Wait, what's the original correct here, and what's the patch expected here?
I think original is what is measured, and expected is what they expect. No? Wait, how do they...
No, I
what
don't
does
think
that mean?
so. That doesn't match with what they explain. Because they say, like, the...
Then I'm misunderstanding this graph. Original correct, patched expected. What is original correct? We plot of the original correct answer and the answer we expect after patching. So it's like what they assume.
But the original correct answer, why it's different on red, blue, and right? Why is not all the standard? Why standards? Why is not the original correct? Shouldn't it be standard sampling without patching? Here, the second thing, which is red, is 5 latent vector patches with a better average over prompts with the same template. Okay, patch. So have this. So this is the result of the patching, but what's the expected thing then? Because the patch expected thing is lower. Why should it be lower? Shouldn't you? Okay. I think I understand. This is just badly labeled. I think this is the. Okay, I understand now. So the green one here is the thing without patching.
Yes.
Right?
That's
Here,
my understanding.
it's result from patching on the, this thing, the average with all problems. So, this is the result from patching. And this is what they expected. And it expected to be lower because they're patching it to have the wrong answer, right? So it doesn't actually reduce the accuracy as much as it should. Right. This means that the model is not actually only using a step layer 5, latent 5 to do the intermediate calculation. It's actually doing other stuff on the previous layers that also use the thing. And so if you break the layer 5, you patch latent 5, that doesn't completely change the answer, only reduce the accuracy.
But if it goes up, that means it's more accurate, no? Frequency of the correct answer goes up.
It goes down.
I mean, in the expected. Why would they expect that doing this patching
they expect it
make
to
the
make
frequency
it go down?
But it
compare
goes
this to the green, right?
But the green is next to it. No, and that's extremely low.
No,
that's
but
zero.
Well, actually, I don't know what this green thing is. Yeah, I'm confused. I don't know what the green one on the patch expected is.
I think that's a mistake. That makes no sense to me. Why would they expect frequency of the correct answer to be 0 when you do standard sampling without patching?
Yeah, I don't know. The other ones make sense. I mean, maybe this is just a mistake on the plot. But the other ones make sense, right? Like the other ones make sense that you expect if you patch it will go to 0.1 or something. Kind of makes me want to write a comment asking them, but probably.
I was also thinking about the comment. That's the thing I'm so confused about all this time. Why is this one green 0? Like, what is happening?
But if we ignore that one, the other thing does make sense.
Yeah.
I think.
Yeah, a random completely destroys it. That makes sense. Like, same template destroys it somewhat. I would expect cross template to destroy it a bit more than just this. And
no, but this is what they expect. Turns out neither of them actually destroys it that much. I think because there are other mechanisms that already get the model to get this accurate on 4, right? That don't use the fifth step. The fifth step only accounts for like this, from 0.3 to 0.5 or something. So it's
also on the 5th step. And like the model can be like, on the 6th step, I'm just gonna compute what was patched or something like that.
I think there is just multiple paths that start earlier, and that also explains why you have non-trivial accuracy on step 4 already, right? And when you destroy the path 5, the 5th latent, you are just breaking whatever is new on 5 that was getting the accuracy from 0.3 to 0.5. And that's why you get like 0.3-ish here, like a bit less, but yeah, that's also because it's also confusing it. But yeah.
Yeah.
The model
Let's also ask Claude.
Calculate both intermediate results and the final answer from user prompt alone, performing a form of internalization. We not investigate how often intermediate. I mean, yeah. Although in step 0, it kind of does. So
Let's see if Claude is also as confused as we are.
Okay, so they do this is interesting. They try to make it to test if they got the latents are enough to do the thing. So they we have a later presentation with specific numbers.
Okay, Claude is either hallucinating or what?
What is Claude saying?
The patched expected answer. No, not patched.
I mean, Claude can't release a graph, so
I gave him the graph.
I mean, Claude is
it is
extremely
hallucinating
blind
right now. Yeah, it is true for multimodality. Anthropic is best in text, basically. Gemini is good for multimodality, but that's worse in reasoning in general.
That's how performance changes. Okay, so I think the ablated thing is interesting. Then we test how performance changes when we patch one original latent vectors change over different prompts with the same intermediate values, or latent vectors average over prompts with different intermediate values. The model recovers over 20% accuracy in both cases. These two, most information is stored in the latent vectors. Instead, the intermediate calculations.
Oh, wait. I think it makes sense actually. If Claude isn't hallucinating again. I need to double check. Claude is saying that you're patching the origin the
You could just look at the code if you guys are
patch.
confused about this.
Oh, if there's
so
code,
like it makes sense. It makes sense that it would go to 0 if you would patch, I don't know, 36 with 37 or something like that.
There is a code, so we can just figure that out.
No, wait, they're saying no patching.
Why assume Claude based on reading? Just assume based on go to experiments. They're all in experiments.
Okay,
I'm not gonna use Claude.
You see, you see the latent patching? Just click on that.
Okay. Step 2, latent patching.
Oh, I'm tired. It's like too long.
Understandable.
I'm just.
I mean,
my POV. It looks like you guys are keep on backtracking constantly.
What?
It's been 2 hours it's also pretty. We can probably end it. Okay, let's first finish reading my paper and then we look at that.
I think we should not do Scratchpad. Like, I honestly don't think it's worth the time. And also, looking at how you're backtracking constantly, I don't think you guys could go through Scratchpad without backtracking. We're gonna
let's finish this and then I'll look at the code for this one. But let's skip that. Okay, so now they're doing interesting thing where they try to ablate the numbers, right? The representations on the original prompt and also ablate the latent vectors. And so if you do, so the standard has this: if you ablate the prompt, it doesn't work. And if you ablate the prompt, but you add the latents, it kind of works. Like it has some accuracy, right? Similar to the one when it patches. And if you wait, what?
Recover? What do they mean by recover? If they like destroy them?
Where?
When we patch original latent vectors.
Can you send me the line where that is like?
Ablate the representations of specific numbers. Oh, okay.
Okay. For each prompt, okay, yeah. So
standard mean ablation and completely destroys the accuracy. No.
different prompts. I mean, they are doing weird things with the model. It doesn't. Sparkling breaks.
What is happening here?
Are they replacing the prompt by the mean of the activations. Is that what's happening?
Yes, they take a bunch of different prompts and they replace the prompt part with a mean of that. Yeah. And here they have the standard. Here they have they just apply the prompt, and that completely breaks the model, which makes sense. But here they apply the prompt and they so patch latents here. Okay, so
the second is latent vectors average over different prompts with the same intermediate values. And the third is...
Wait, so this is a ablated prompt and a mean ablated with the same steps and latents, and that works better than the mean ablated prompt without the latents, apparently. Without changing the latents, I mean. But that doesn't work worse than cross latents. Oh, the same.
I didn't look at this part too much yet.
Okay, so the same values make sense. Okay. So the different values doesn't make sense. But I
Wait,
still.
so
what are
they
doing on the first?
They destroy the prompt and they destroy the latents, and accuracy goes up compared to just destroying the prompt.
No. Yeah, but not only that. Apparently, if you destroy the prompt and don't change the latents, that breaks the thing. But if you destroy the prompt and replace the latents with, like, you mean ablate the prompt, but you mean ablate the latents, but with the same values, that works better than not ablating the latents at all.
I think what's happening.
What?
I can see why, kind of, maybe.
Some kind of alignment. But like,
I think...
in what way? Go ahead.
Oh, I was saying that I think that what they're trying to show is that the like the concept, I guess, for the correct number is being stored, like, is generalized across different prompts, right? Because the mean all prompts plus cross latents, that's just averaged when it's the same response, right? Like the same number, essentially.
Let me reread it.
Okay. Let me read the discussion. Then I want to see the code for these last two things. And I think that's mostly it. Let's not read the Cody paper today. I think we more or less got an idea of how it works already.
I hope my directions to like the Cody paper, the diagrams help explain some parts.
I think it helps, yeah.
Yes.
Kind limitation. I also think it's interesting your own research thing that you mentioned is kind of interesting.
You should publish it.
I did a less strong post. I'm making the second one. I'm doing a weekly less strong post for this. I'm just doing weekly less strong posts.
Nice.
Nice.
I finished both of them. It's just I can't publish it, the second one, because I don't know. I don't know what's the error going on the less strong editor.
Maybe I can look into it.
I asked support like 2 days ago. Support hasn't responded.
Oh, maybe I'll look into it and maybe it's something obvious. I don't know.
Last strong, also like the Cody model, specifically the ones that were used for this paper, or like for the last strong post specifically. I honestly don't think too highly of it might not be a good direction, because I realized that if you give it a prompt like what is your favorite animal, or like what animals fly, it outputs the answer is number.
So it's basically overfit.
It overfit. No, but it's only able to solve math questions. But you're able to put in more difficult questions than elementary school, and then it was able to solve it. So it's able to solve harder math questions, but anything that's not math, it sucks.
So it's overfit to math, basically. I see. That's funny.
Yeah,
What
it could give
model
a
is
number. It could give a number as an output to like, what's your favorite animal?
Sorry, is this the Cody model that was overfit to math, or is the original?
Yeah, the Cody model. I found that out like this weekend. So I was like, oh, maybe this was all a waste of time.
Well, it's generalizable to all fish. Well,
But it
partially
generalized to math
generalizable.
questions outside the GSM2K, and it did better on like harder math questions. So so it works on math. Anything.
Generalizable to some, like the techniques and stuff, could be generalizable to some kinds of latent reasoning models, but it seems like a lot of it might not actually. It might not work with the actual latent reasoning models that are doing actual latent reasoning, that they are not doing verbalized reasoning with
Maybe the lack of verbalizations is why it sucks at anything that isn't math. That could also be that.
I don't think so. I think it's just overfit.
Yeah, it's overfit.
Yeah, it was trained on it, yeah. Makes sense if you don't train on general data and mostly on math.
How would you train a latent model that works on non-math questions? And how would you evaluate?
Well, you train it, you just add more data. Here they trained on basically math, so it makes sense that it will overfit to math.
I mean, on the
you need to train
QA
it on the general.
You just get it to answer the correct QA questions. Like there is a lot of benchmarks you can train on, right?
Yeah, but for common sense, I think it did worse when you tried to do the latent training, right?
Yeah. So here, no, I actually did a bit better, but probably not significant.
Yeah, that looks. Wait, no, it's worse. It is worse, no? Yeah, it's instead of 67, it's 66.
Wait, no, but
compared to direct answer. Compared to the first one.
Oh, wait. But this is because the answer is somehow better than Jacob thought. Jacob thought makes the Q&A worse.
Also, I'm having a bit of issues with
the common sense answers there.
Also, I think this evaluation is kind of has some issues because the direct answer is already the model that is trained to do latent reasoning. So I would assume that if you make the model enforce it to do the 6 steps, and then you evaluate it without. Wait, do they do the 6 steps? Yeah, I think they don't do this. No, do they?
For all this, it's the 6-step version, I think.
But latent isn't the latent A chain of thought created by doing the 6 steps? Am I misunderstanding it?
Yes, you do 6 steps.
You're able to have the latent reasoning put in n number of latent steps. It just they only trained the setup to do the 6 steps.
So the direct answer is just doing 1 step then, because you don't do the chain.
Oh yeah, here's how the logic lens looks like if you use the 6-step latent reasoning model and then you try.
Yeah, and this is, I think, wrong evaluation. Like if you train the model to always have to do 6 steps, and then you evaluate it on doing no steps, like 1 step only, then of course it will do worse.
But it does better.
No.
On math at least.
On common sense, it does better.
Okay, on math at least.
No, I mean in common, but actually,
I have issues with this evaluation. Like they're like, no, you will always do 6 steps, and now we will evaluate, and you will overfit to that, and now we will evaluate you on 1 step.
To be fair, you are fine tuning a llama model that was trained on all kinds of steps already, right? So
yeah, you could say that as well, yeah.
Also, do they actually but they also train it on the direct answer. I think you're wrong. So we train a single model that can operate in 3 modes. So they also train it on the direct answer.
I'm wrong there. Okay.
So it just turns out it requires. So the model is better at doing math with more steps because it does require multiple steps to do math. Like, I mean, in theory, the model could learn some bespoke parallel algorithm and do really big math operations in one single step, but not even human brains do that. So it doesn't. I think it makes sense. It's very hard to learn because that kind of thing requires is the kind of thing that you need to do or learn all at once. That there is no. It doesn't have smaller parts that on their own do stuff. So it's hard for it to get great descended all at once.
Also, they're looking at the 1B llama models, which will be terrible instantly.
Yeah, I mean, they're okay for this kind of math. Or like, well, it's 42% accuracy on that bit, but it's still better than much better than chance.
Yeah.
Here
yeah.
though, wouldn't they? Aren't these models also being trained to sort of, for the latent reasoning to sort of replicate the chain of thought reasoning as well to some extent? So in that case, the chain of thought's probably already going to have multiple steps in it. So if you're aligning the chain of thought and the latent chain of thought, then it's going to be like it's not going to be able to learn a parallelizable algorithm, right?
It's not learning
Yeah,
the steps.
but
of the chain
I
of thought.
mean,
It's
I
only
mean
learning
that's
the
also why the chain of thought, we require chain of thought in the first place. That the original model didn't learn some parallelizable algorithms, and the models are bad at direct answers. All like llama, even the biggest llama, are not that can't do really big arithmetic. Like, and no model. There is no frontier model that can do really big arithmetic on a single step, right? Even though they are doing very big matrix multiplications, and in theory you could do it, but it's just very hard for grade descent to learn that. It also probably will require a lot of space on the weight, so maybe that's also why. I don't know.
Mm-hmm.
But this is also true for humans, right? Like in theory, your brains could learn to intuitively when we want to multiply 6-digit numbers instantly know it because a lot of more neurons did something very big thing in parallel, and instead we just like number by number carry one and so on.
We don't. I don't know how about you, but I first compute approximately when I do big computations, and I'm wrong because it's often good enough. And if I really precise,
the
I go
models
to the algorithm.
Can do that too.
I think that's what the models. Yeah, like if you look at how the models do addition, like in the biology of Phelan's paper, then it's more into it's more like relatable than if you look at how calculators do addition. Usually.
But I think it's also I think on the I think it's doing the brain is probably also doing the same kind of thing with the spirals and all that, and actually, and I think the reason it's not a large numbers is both cases. I think there's also some neuroscience stuff for that, like the representations are logarithmic and get less precise the bigger the number is.
Makes sense, yeah.
So because if you imagine if you have some spiral like that, there's also like on the counting task thing that was also true that the latents were more dense on the lower numbers, and towards the higher numbers it's like they took less space on the spiral, and it's just like you have some finite space to do the representation and you want to do something relatively small. So, and doing that kind of thing on arbitrarily big numbers requires increasingly bigger, amount of parameters in the model and neurons in the human brain. So it's not worth it to just do less precise representations and get the approximate result.
I wonder if there is something like the place neurons. I think it's called place neuron. I forgot the name. Or time neurons. I don't think they are called like this. Place cells. That's what they are called for like arithmetic. I wonder.
Yeah.
But since arithmetic actually but it's relatively recent. Like 5,000 years or something like that. or more
It doesn't matter what
like.
people. I expect that you learn something like that if in the human brain. If you get when you get a kid to learn to do arithmetic, they'll maybe learn something like that when they do intuitive arithmetic on their heads. I don't know.
Mm-hmm. Literally, you
This
learn
is
a circuit
we are
maybe.
getting too speculative at this point. So
Yeah,
who knows?
I agree. I wonder if there is research on math reasoning in brain. I have some papers like that bookmarked, but I never read them.
Yeah, I will have to read it. But yeah, like in theory, you could do something that scales better when you do the same kind of, there is some bespoke algorithms where you do carrying, but you do it on parallel and you do a lot of numbers at the same time, so you can do the same operation on each number, but in parallel in some nice ways. And you could imagine, like, you could hard code that in a transformer and it will work. It's just
Yeah. Do you know the
train the set
savant?
doesn't learn it, and it seems I can see why it will be very hard to learn.
Yeah.
And
Do you know the addition competitions of the like the people of the nerds that like compete for doing addition basically? Like they almost always use their hands and like compute it in hands using some algorithm basically. They don't do it in the brain as much, I think, or something like that. I'm not sure if you've seen that.
Sorry to detour. You mentioned an algorithm, Chambol Pok, or something else?
Can you say it again?
Victor mentioned a name of the algorithm. I couldn't hear that algorithm.
Maybe you misunderstood me or something. I'm not sure. What algorithm for what?
For parallel.
Oh no, I didn't. I don't know any specific algorithm for that. I just made that there are. I think I just said there's some nice. I don't know. I remember what I said, but I just meant that there are nice algorithms to do it in parallel. I don't know much about that, but I know they exist.
Okay. Okay, just asking that.
Yeah. We are kind of generalizing the biology of Alan's paper to the brain, I think.
Yeah, I don't
which
think
might
that.
be completely wrong.
I don't think that might work.
Or like, not. I wouldn't say generalizing, more like partially generalizing.
Wow. I was investigating another token, man. Partially, it's not. Here's like the therefores when you do.
Anyway, I think so. We mostly read this paper, kind of. I guess apart from the last thing I want to watch is the code. And also maybe Relmer has something interesting to say, but apart from that, yeah.
Yeah. Oh yeah. Here's the ones with only latent 5. This is how it looks like. You can see it's like a bunch of therefores. This is what maybe even look at therefore.
Oh, nice.
Yeah, like yeah, and over here you can see the tuned lens, the different variations I tried. I put it in the last run post. This is incomplete since I did like another one afterwards. That's a follow up. But yeah, if you do the if the only ones that show the final answer emission is the tuned logic lens, where you do it on like latents. 1, 3, and 5 only show 10, which is kind of interesting. And they show in between like the middle layers, with the exception being the first. This one was even. Here, did I copy paste it wrong? No. Oh, yeah, this is what. Yeah, this is the full tuned logic lens.
Get up, yes.
If you look at the non like normal logic lens above latents 10, for the. It's interesting what it outputs. It like repeats. It actually has different patterns until latents 14, and then it repeats the same latent output. It doesn't use the end of COT token unlike the Cody one. that's around it. No. I just don't know why I can't like copy paste it. Like I literally every time I try like doing the new LessRung post, it gives me this error. I honestly don't know what's going on.
What error? Missing response for batch query. Yeah, that is some backend bug.
No. Every time that this only happens when I make my posts, like if I put like 10% of my post or like 20%, it's fine. But the moment I put all of my post, it fails. But the individual parts work. So I tried doing it segments by segment only, and it saves and like could like save, right?
How about making a post, then it's posted, and then you edit it?
I tried that.
Doesn't work. Okay. You could contact LessWrong support or something.
I did contact them. They never responded. 2 days. I was done with this. I was done with the content for a while. The only
Maybe
issue...
it's just too big or man. I seem very big proposal.
This?
I don't think it's too big.
Yeah, I know it's not too big. You're right.
It just this week, like starting from last week, the new UI, and then now I can't update my post, or now I can't.
Yeah, there were some bugs. I've seen someone on the main page complain about some bug already, so like, maybe they will fix it.
I mean, maybe you just need to wait for a few more days, and you can work on something else in the meantime.
Yeah, that's the newer responses. That's where, and then I also found interesting things about the convert token, which is interesting. When you put in like non math questions, there's a lot of the word convert. I wonder why. The questions that like does bad on has the word convert.
It's trying to convert it back to math because it's in unfamiliar territory, just like some autists.
Or something about like like something about like the non-math questions like seem to like make it do wrong answer, plus it seems to like want to convert. It just says convert.
I wanna come back to math. Stop torturing me with math noise.
But isn't that funny? Like I used logic lens, like I use different variations, like across the tune variations, like it just says convert. It's like what
That's funny. And I actually wonder if it's really random or if it's like some logic.
Maybe it's trained to only be able to do math, and it knows it's not math, so it just like hates.
Maybe I wonder if you put the convert token into the convert the vector into the normal llama model, it makes it talk about math.
And also like if you train logic lens on like Cody, like it just doesn't generalize to the non-Cody things. But if you train Tune Logic Lens on normal tokens, it works on Cody latents. So you could go from normal token Tune Logic Lens to Cody latent reasoning, but you can't do the reverse. That's some of the things I found with Tune Logic Lens. Cool. Yeah, this is the random post I did. Yeah.
Is it okay if I ask a non-expert question? I'm trying to understand what you guys talking.
Okay. Yeah, it's okay.
Okay, so like when we have this GSM 8K corpus dataset, and what kind of representations are being created or being made by the LLM? So basically, during this, when they apply COT on these discrete tokens, can we get to know about what kind of representations are coming in for this dataset, GSM8K? And in a sense, how do we measure the interpretability of the implicit steps, or like the steps in between? Is my question.
Okay. I think I know maybe what you mean. So the thing they are doing here is just logit lens, and logit lens is just you take the unembedding, right? So like the last layer where you take the last activations and convert them into words, and you apply it to earlier layers, right? And
what is the logic lens? Sorry.
Yeah, so the logic lens is
Logic lens, okay.
An embed of the model, which is the part of the model at the end that turns the last layer's activations into words. Does that make sense?
Yeah.
Okay. Okay.
And you apply it to earlier layers, or in this case, maybe also the latent thing.
Okay. So when you say latent step, right? Is
Here they are doing the thing where the model, this model site is this latent reasoning models output vectors instead of words, right? So they are missing the unembedding. So we are just applying the unembedding into those to get words from them.
Yeah. Like there are latent steps here, which are and there are also latent layers on their own, which might be slightly confusing.
Yeah, I think that's probably confusing.
Yeah, so, latent vector index and layer.
I'll explain first the original latent, the typical logit lens stuff first. Okay, so the normal logit lens thing is the model has a bunch of latent layers, you have a bunch of layers, and it has some latent vectors in there, like the activations on that layer, and we don't know what they do. So a kind of hacky theme people came up with. It's more than 1 year ago now, which kind of feels weird. So it's you take the unembedding on the last layer and apply it to that layer, to the activations on a previous layer as if it was the last layer, to get what that latent will decode in words.
Okay.
And that sometimes makes sense, which is a bit surprising sometimes. Because that doesn't, it wouldn't need to be the case that the model has a word there until the end. But you sometimes find things that make sense there. Like in some sense, the model is thinking about some word earlier. In that the activations of the model in that layer has look like the representation of some word on the last layer.
Okay. So basically, if this COT, which is improving LLM reasoning, which is on discrete token, I mean, it relies on discrete token generation, right? And the question is like, if latent steps are used, which is kind of a continuous thingy, then how many steps do they assign before, let's say, if they have to do some task for this GSM 8K corpus?
They
basically
do say 6 steps, like on this dataset. They just always do 6 steps
for this dataset, right?
But I think that they say they do it for both the math dataset and the question dataset. But yeah, I think they just did 6 steps. Although the other experiments, so they probably just they only tested on the math one. So yeah.
Okay. Yeah, sorry for my silly question. I'm learning and I'm starting to enjoy this discussion. I joined one time before, but couldn't understand. I come from math background. Yeah, sorry. Thanks a lot for.
No, it's you should ask most questions. I think it's good for people. I prefer for people to ask silly questions that just be quiet, not understanding the whole time. And I feel like, for example, Redbird used to not know a lot, and he increasingly knows more, and he's doing his own research now. And that's why he also asks a lot of questions, and I think that's
okay. Sorry.
Yeah.
Oh, suddenly. Okay. Why did I click on the
Phil, do ask dumb questions if you are not understanding. I much prefer that just me talking alone for 1 hour and nobody having any idea what I'm saying.
Well, though I still did not understand. Let's say we have a data set of some, this GSM or some matrix multiplication or something like that. So, what does a single model, what kind of representation it builds along the way? Representations along the way. Let's say you want to do just matrix multiplication, you want to learn a table or something, bit multiplication table, something like that. Do we know what kind of representations these models learn? Let's say
No.
llama or no?
No.
Okay.
Not
Like,
in
So
general.
how do they decide then? Like
we know
let's say I ask
there is some examples of some representations we do understand, but it's like there is more than we do understand that we do.
which
And
model
a
or
lot of like a lot of Mech Interp techniques are like extreme approximations. So like if you come from math background where everything is exact and fancy, then if you go into empirical sciences, it's a mess of approximations. So what Mech Interp I feel like is doing is like you have these giant black box models that are giant approximators to some degree, but not really, because they also form circuits that make sense and so on. It's nuanced and so on. Then we take these approximate methods to reverse engineer them that approximately reverse engineers these approximate black boxes, and then you can do even like one more layer of approximate reverse engineering of the approximate. It is mess, complete mess without certainty. But you can have some causal results, like you can do steering and stuff like this, so it's not complete noise. Yeah, I'm not sure if that helps.
Okay, so this reasoning, can you, like, are these discrete COD or continuous version of it, or like some sort of
Discrete.
distribution, discrete COD?
Yeah, it's over
So
discrete tokens.
On this
so then,
specific post, so on this specific post, they do both. They have a verbalized COT, which is just the discrete tokens, and the latent COT, which is the new thing, which is they output the latents.
which is continuous, right? Latent
Yes.
means continuous, right?
Yes.
Okay.
And it's
So
like a bigger vector, like a vector with maybe like 1,000 dimensions or something.
So okay, and on which dataset latent is doing good? Can you please help me understand this table? Like
it seems like the latents do more or less like they're doing a bit better, maybe, but it seems they more or less they does the same as they verbalize. And this makes sense because on this method, the thing is they are training the latents to be more similar to the latents on the last layer of the verbalized version.
Okay. So not on discrete. So the self-distillation procedure is a continuous phenomena. Some sort of continuous representations are being made. So
the verbalized part, right? The verbalized version generates some discrete, like has some continuous representation that then turns into discrete things, right? And the thing is, they are trying to take the representations before the part where you make them discrete and make them into a token, but by sampling, to they taking the activations before that and try to make it more similar to the activations on the latents after that, on the continuous version. I'm not sure if I explained it correctly.
Okay.
Yeah, like
I'm still thinking.
Yeah,
I
think
there was a sense I understood mathematically that what LLMs do, or no, okay, not transformers do. I think there's a one more layer of complexity when you can separate them both. So for transformers, for like in context learning, at test time, they are able to do reasoning, right? So what does that mean? What does that mean? Mathematically, in certain cases, for example, you have a Gaussian distribution, let's say on beautiful paper math, you could say that when on test time and it's doing reasoning transformer, it is emulating the behavior of multi-step gradient, so some gradient method, okay? It could be Newton method as well. If you change the distribution a bit, if you take off one normalization, or if you take off, I don't know, what is it called, residual connection, so you get a different algorithm. So let me repeat what I just said. On paper, when you take a very simple distribution, data distribution, transformer at test time, while doing reasoning, or let's say in context learning, it can emulate the behavior of some sort of gradient-based method. Okay, people proved it. Looped transformers
I've seen that.
Sorry?
I think I know what paper you mean, yes.
Yeah, there are literally 700 papers about this. Okay.
Yeah.
Like,
and,
I think
yeah.
or go ahead.
Yeah, this is just for like, a conceptual, shallow mathematical thing, okay, for transformers. And even in a very specific cases like looped transformers where weight sharing is involved, or self-attention networks, you can write the mathematical definition of the networks, architectures, okay? So that kind of tells you that if this emulation, that means of some optimization algorithm, that means you kind of know the representation step by step. Okay, so that's kind of an interpretability way to say these things, and many mechanistic interpretability papers cites it. But when it comes to real models, all of them use transformer in certain way. Of course, there are many MLP layers than just transformer in any big LLM, and there are domain-specific LLMs, right, or foundation models, whatever things people made up. I mean, there's so much out there based on different data distribution and different tasks. And interpretability should be specific to a tuple, which is like you fix your data, fix your architecture and algorithm you are using underneath, and whatever task you have. So in that case, you can actually, using this idea of emulation, you can say something about emulation, like what kind of interpretable representation you are getting. But that all looks good on paper for continuous settings, right? But in reality, we know, we have discrete token embeddings. We have discrete tokens, right? So I'm not really sure I understand anything about COT. However, it just means chain of thought, like some sort of compositional behavior of certain length. Let's say, I don't know, like 10 steps, you say multi-step reasoning and so on. But so my question to you guys is like, you have read a couple of papers in this group. Is there any consensus when it comes to, let's say, mathematical task, mathematical data set? And let's say we assume that they all use the similar transformer, all kind of models, LLMs, and like a bit of change up and down. Is there a consensus that for discrete COT better for math, or continuous COT better for math data tasks? And also, this data tasks are highly data sets are like curated, right? So, like for example, Olympiad data set, mathematical Olympiad.
Okay. So
there isn't data yet.
Okay.
I mean, I
sorry.
think so. The problem is the continuous COT thing is very new, and the thing we were discussing earlier is that it doesn't seem the current methods are very good. Like I think the current answer is no, because there is no good. Well, maybe this new paper that Bernie was mentioning, where they looked at, but that's not really the same. So it seems like there is just no very good continuous COT stuff, right? Mostly is everything is discrete, like all the frontier models and all that is just doing discrete COT. They are not doing this latent thing where you do continuous COT. And
Okay.
there is a few papers, but there is no like really good paper that shows that it has much better results that don't turn out later to have a lot of problems.
Yeah, a few papers seem to have minor improvements, and the question is if this even scales to the trillion parameter regime and so on.
Yeah, like we don't
We have no
really
example of
big, GPT 4 size latent reasoning models to test to compare. So who knows?
Like intuitively, I would say yes, but we need to falsify that. So
Yeah, and even then, it seems like it will be hard to train them well without doing this kind of single destination thing where you're just copying the performance on the other thing, because like part of why the current methods where you use chain of thought with tokens work is because you are training on the internet and you have some examples of humans reasoning out loud to imitate first, and then you do reinforcement learning, but you do reinforcement learning from already having some things to work from, so the model sometimes gets the correct answer by imitating some kind of reasoning, and then that's much more efficient than trying to do reinforcement learning from scratch. For the same kind of reasons why, for example, if you want to train, there was a thing where the OpenAI trained models to get diamonds in Minecraft, and it's much easier to the thing that worked was training first on imitating humans playing the game than training with reinforcement learning to the thing, because reinforcement learning from scratch just starts doing random things, and if it never does anything right, it will not get reward and it won't learn anything. So that's the same kind of problem you will have on like this kind of continuous latent reasoning. I think this kind of, maybe you can in this first training with this kind of self-distillation to the same kind of thing as the chain of thought and then do more reinforcement learning on it. But I don't think nobody has done that, or maybe they have, but it's some new paper that I haven't read yet.
Okay.
So
what if this measure, the way to measure this difference between different COTs, self-distillation, is not enough or not correct? Maybe we need some different procedure, not the teacher-student way. Or
I believe
Oh yeah,
so.
maybe we do.
that
We
obvious?
just
Like
people haven't found a way that works.
Is it
It's
Or
that
probably
like
obvious
some
you
other
that
way.
you could think of ways
this
to
is
do
the right way
continued
to do
COT,
it?
but all of them do worse than normal COT.
yeah, like I think here you just force the model to literally behave the same way. Like if you just weren't doing if you were doing the unembedding step, like if you force it to have the same representations, like if you do the unembeddings, each autoregressive step. So like I think this is not really good setup for actual latent reasoning. But
Okay,
like after you do that, then you will not be able to interpret it using logit lens, and we will need other methods.
So
in the discussion here, yeah, go ahead.
So there's no method out there, and with the given like some setting of some model that say that this is what this LLM is doing. So even though it's a small baby one for this data set, and they can 100% match it. Is it?
There's
Is
no
my
such
question-
thing as 100%
Yeah, no.
for
There
giant
are
LLM
some
models in
people
Mech Interp.
have manually done that for very small LLMs, but the method is ad hoc, running a lot of experiments and looking a lot of the graphs until you understand it.
The only time we have 100% reverse engineering, well, which is, I would say it's still not completely 100% sometimes, it's like very toy models. Like if you train on a modular edition, a small 2-layer transformer, or like or sorting a list, or max from a list, and so on. Like these toy models, yes,
like there is
kind of
famous paper from Neel where he reverse engineered a model that does modular addition and figure out that it does this algorithm.
Could you please? Which paper is that?
Oh, it's progress measure for working via mechanistic interpretability. I'll send it on the chat,
Yeah.
on the voice chat thing. But there is only a few other papers like this that have reverse engineered a model. But the way Neel did was basically just spending a lot of time looking at the plotting things for the model and noticing himself that it looked like if you took the Fourier transform, there was some periodic pattern, and if you took the Fourier transform, you get very few, that it turns out the embeddings were a combination of a few pure frequencies. So then plotting that, but this was like a one layer model, right? Very tiny one layer model, and there is a few other papers like this, reverse engineering like one layer models, and there is some, but there is no automatic method. There are some attempts at doing that with sparse encoders and that kind of thing, but they don't work perfectly yet where you can automate doing that.
The supervised interpretability, or like the ones that people manually do.
Yeah. And like there are a few papers reverse engineering small bits of bigger models. For example, a cool one is we talked about this earlier. This when models manipulate manifolds, the geometry of a counting task, where they.
I think this is the best Mech Interp result we have so far right now.
Yeah, so they figure out how the model counts the length of a sentence to see when it has to do a line break, right? But then this was also a lot of, there are some other methods that they use for this, like with the sparse encoders, and they do attribution graphs and all that kind of thing. But still, there are a lot of parts of this. This was them manually looking at graphs and figuring out.
By the way, you're not showing stream on the YouTube video. I just noticed.
What?
For the past 2 hours, you're not showing stream on the YouTube video. I just noticed.
Okay.
What measures are you using to say that this is a good idea? Say.
I feel like we should end the stream. This is probably since we probably finished the paper.
Yeah, this is a silly discussion, please.
Oh yeah, okay. It's right. We should.